Hello everyone. In the previous session you have studied about some theorems and finding the inverse of a matrix. Now we are going to solve some problems based on that. If you think that you can solve those problems, then no need to watch this video, or else you listen here. See, it is given that if A is equal to matrix is given, this is a 2 by 2 matrix. Show that A square minus 5A plus 7I is equal to 0. Anyway, this is a simple one. Hence find A inverse. You can find A inverse by using formula or using a transformation law. But here, by using this one, you have to find A inverse. Is it clear? First, you have to prove this is equal to 0. Then, by using this equation, you have to find the A inverse. First, we will prove this one. First, we will find A square. So, we have to multiply A and A. 3, 1, minus 1, 2 into A square, right? So, A is multiplied twice. So, this is equal to 3, 1, minus 1 and 2. We will multiply this. 3 into 3 will be 9. 1 into minus 1 will be minus 1. So 3 into 3. 3 into 1 is 3. 1 into 2 is plus 2. Next will be minus 1 into 3. Or 2 into minus 1. Next minus 1 into 1 minus 1. 2 into 2 will be 4. So this is the A square value. Now we got A square as 9 minus 1 will be 8. 3 plus 2 is 5. Minus 3 minus 2 will be minus 5. Minus 1 plus 4 will be 3. So we got A square. Now we will substitute in this directly. Okay. A square minus 5A plus 7I. We have to prove this is equal to 0. So A square, I will write this one. 8, 5 minus 5 and 3 minus 5 into A. So you have to multiply each and every term of A by 5. So I will multiply this one. So 5 into 3 will be 15. 5 into 1, 5. This will be now minus 5, right? 5 into 2 will be 10 plus 7 into I. Here I is the identity matrix of order 2. So this will be now identity matrix is 1, 0, 0, 1. If you multiply by 7, 7, 0, right? 0, 7. Now we have to add this one. So this is now 8 minus 15 and plus 7. So 8 plus 7 will be 15, minus 15 will be equal to 0, right? So this is 5 minus 5 will be 0 plus 0. So this is equal to 0. Minus 5 plus 5, 0. Here 0 is there. So this is 3 plus 3 will be, 3 minus 10 and this will be minus 7 minus 7 plus 7 will be 0. So we proved this is equal to a 0 matrix. Is it clear? We proved the first step. Now we have to find A inverse. Find A inverse by using this equation. Let me write that equation. A square minus 5A plus 7I is equal to 0. This is now equal to 0 because we proved this is equal to 0. So A square can be written as A into A minus 5A plus 7I, okay, is equal to 0. I will write this one is equal to minus 7I. Is it clear? Plus 7I is there. So this will be now minus 7I. Now we will multiply A inverse to the right side. If I multiply A inverse to the right side, this will be A into A inverse minus 5A into A inverse is equal to minus 7I into A inverse. Is it clear? A into A inverse. So this is A into A inverse will be I minus 5 into I is equal to minus 7. I into A inverse will be A inverse, right? So minus A inverse. Now we have to find A inverse. So A into I can write A minus 5 is multiplied with the identity matrix is equal to minus 7 A inverse. We need the value of A inverse. So A inverse can be written as minus 1 by 7 into A minus 5I. Is it clear? Before this, one more thing, you have to check the determinant of a matrix. If it is a determinant of a matrix is equal to 0, then the inverse does not exist. First, we will check the determinant of a matrix A. What is the determinant of A? This is 3 into 2 will be 6. So this is minus into minus will be plus, that is plus 1. Determinant of A is 7. So 7 is not equal to 0, right? So the inverse of a matrix exists. Now we will find this one. So this is equal to minus 1 by 7 into matrix A. What is here now? 3, 1. We will substitute this 3, 1 and minus 1 and 2. So this is the matrix A. Minus 5 into I. So identity matrix is multiplied with 5. So this will be 5, 0, 0, 5. So this is equal to A inverse. Now we will simplify. This is equal to minus 1 by 7 into 3 minus 5 will be minus 2. So 1 minus 0, 1. Minus 1 minus 0 will be minus 1. 2 minus 5 will be equal to minus 3. So this is the inverse of a matrix, A inverse, right? So or else you can multiply by negative sign. If you multiply by negative sign, this will be 1 by 7. This is now plus 2. So this is minus 1, right? This will be now plus 1 and this will be plus 3. This is the inverse of a matrix. How to check this one? You know the formula, right? What is the formula? A inverse? A inverse is equal to 1 by determinant of A into adjoint of A. Anyway, determinant of A is there, that is 7. 1 by 7 into adjoint of A. 2 by 2 matrix, simple it is. You have to interchange these two elements. It will be 2 and 3, correct? And you have to change the sign of the non-diagonal element. So this is plus 1 is there. Here we have minus 1. Minus 1 will be plus 1. So this is the inverse of a given matrix. Simple problem this is. For the matrix A, find the numbers A and B such that the condition is given A square plus A into A. This is a constant A into A plus B into I is equal to 0. Just you have to substitute in this. First we will find A square. So A square you have to multiply this, right? 3, 2, 1, 1. So this will be now 3, 2, 1 and 1. So we will multiply this one. So 3, right, product. This is now 3 into 3 will be 9 plus 2 into 1 will be 2. So this is 3 into 2 is 6 plus 2. So this will be now 1 into 3 plus 1. So this is now 2 plus 1. Right. So A square is equal to now 9 plus 2 is 11. 6 plus 2 is 8. 3 plus 1 is 4. 2 plus 1 is 3. Now we will substitute this. A square is, we got 11, 8, 4, 3. Right. Plus A into A. So we have to multiply matrix A with the small letter A. So this will be now 3A, 2A and this is also A, right? Plus B into I. So identity matrix is multiplied with B. So identity matrix of order 2 by 2. Then only the addition is possible, right? So this will be now B 0, 0, B that equal to 0. 0 means the 0 matrix of order 2 by 2. So this will be now 0, 0, 0, 0. Clear? Just we'll add this one. So this is now first term will be adding means you have to add the corresponding terms. 11 plus 3A plus B. Second term will be 8, right? Plus 2A plus 0. Third will be 4 plus A plus 0. Last will be 3 plus A plus B. So this is equal to matrix 0, 0, 0, 0. Any values you can equate. Anyway, here 4 plus A is there. So if I equate there, 4 plus A is equal to 0. A is equal to minus 4. I got the value of A. Now I have to find B. Any value 3 plus A plus B is equal to 0. You can equate with any value. 3 plus A plus B equal to 0. So this is now 3 minus 4 plus B is equal to 0. So 3 minus 4 with minus 1 plus B is equal to 0. So the value of B is equal to 1. Is it clear? The value of A is minus 4 and B is equal to 1. You have to find the numbers A and B. See here, this problem is little lengthy. So I have written the solution here. For matrix A, this matrix, you have to show that A cube minus 6A square plus 5A plus 11I is equal to 0. I am not going to explain this one because already you have studied this one in the matrices. So you can solve this one. First you have to multiply matrix A 3 times. Then A square you have to multiply by 6. Plus you have to multiply matrix A by 5. Then identity matrix of order 3 by 3 you have to multiply by 11. You have to add and subtract everything. Then you have to get the matrix 0. Then now you have to find the A inverse. Hence find A inverse by using this equation. Now I am going to explain only this one. Finding the A inverse. Already have written the solution here. But let me explain this one. Okay. See here. I have considered the equation A cube minus 6A square plus 5A plus 11I is equal to 0. Now you have to multiply A inverse to the right side. So this one I can write as A cube as A square into A. Okay, I will multiply by A inverse minus 6 A square can be written as A into A multiplied by A inverse plus 5 A into multiplied by A inverse plus 11 I into multiplied by A inverse. This is equal to 0. So clear? Now we will multiply this one. We will write this A square. A into A inverse will be I minus 6A. A into A inverse. Here A into A inverse is I. Here A into A inverse is I plus 5 into, this will be A into A inverse, again this is equal to I, plus 11, I into A inverse will be A inverse, this is equal to 0. Now A square into I can write as A square minus 6A into I, so this will be 6A plus 5 into multiplied with the identity matrix, so this is as it is 5I is equal to minus 11A inverse. Now I need the value of A inverse, so I can write this one as A inverse is equal to minus 1 by 11 into A square minus 6A plus 5I is equal to A inverse. Is it clear? Next you have to substitute minus 1 by 11. A square you have to substitute here as told here. A and A you have to multiply these two matrices. So by multiplying that I got the value of A square. Just I substituted the value of A square minus 6 into A. Multiplied matrix A by 6 plus 5 into I is the identity matrix of order 3. So multiplied identity matrix by 5 is equal to A inverse. Is it clear? Just next simplification. 4 minus 6 plus 5, it is equal to 3. 2 minus 6 plus 0, so it will be equal to minus 4. Next 1 minus 6 plus 0, this is equal to minus 5. Is it clear? Just you have to add or subtract the corresponding elements. You got this one, but here this is multiplied by minus 1 by 11. So we will multiply minus sign to the inside. So this will be now minus 3 plus 4 and this is plus 5. Minus 9 will be plus 9. 1 is minus 1. 4 is minus 4. Minus 5 is plus 5. 3 is minus 3. 1 is minus 1. So this is the inverse of a matrix by using this equation, or else you can go with the formula, right? But here this is asked, this question is now hence this by using this one you have to find the A inverse of a matrix. Simple problem, find the inverse of this matrix. 2 by 2, simple it is. We will consider this matrix as A. So the A inverse will be, first you have write the formula. A inverse is equal to 1 by determinant of A into adjoint of A. Right? Now before finding the adjoint of A, you have to find the determinant of a matrix. If it is equal to 0, then inverse does not exist. Right? First we will find the determinant of A. What is determinant of A? 3 into 2 will be 6. So plus 8. So 6 plus 8 will be equal to 14. So this is the determinant of A. So this is now A inverse is equal to 1 by determinant of A is 14 into adjoint of A. Directly you can write, just interchange the diagonal elements. So this will be 3 and 2. So this will be now plus 2 and minus 4. So this is the inverse of a matrix. If you want, you can simplify this. So this will be now 3 by 14 plus 2 by 14 will be 1 by 7. So this is now minus 2 by 7. So this will be now, right, 2, 1 by 7. So clear? This is the inverse of a matrix. Now we will see one 3 by 3 matrix. Find the inverse of this one. Anyway, we will write the inverse. A inverse is equal to 1 by determinant of A into adjoint of A. Right? First we will find the determinant of A. Determinant of A is equal to, we will delete along the first row. So this will be now 2 into, delete first row, first column. So this will be minus 1, minus 0, right? Minus 1. So this is plus, minus and this is plus. So minus 1 in, delete first row and second column. So this is 4 plus 0, right? So last will be plus 3 into, delete this one and this one. So 4 into 2 is 8 minus 7. So this is equal to now, determinant will be 2 minus 1 will be minus 2 and this is now minus 4 and 8 minus 7 is 1. So this is now plus 3. So this is minus 2, minus 4 will be minus 6, minus 6 plus 3 will be minus 3. So determinant of this matrix is minus 3, so it is not equal to 0. So inverse of a matrix exists. Now you have to find the adjoint. For that you have to find A11, A12, right? A13, then A21, A22. Directly you can find this. A23, then A31, A32 and A33. First we will find A11. So this is now plus, right? If you want to write the signs first, minus. So this is plus and this is minus, plus, minus, plus, minus and this is plus. Now we will find A11, delete first row, first column. So this is equal to minus 1. So value will be minus 1. A12, first row, second column. So this is equal to 4. So this will be minus 4. A1, first row, this column 4 into 2 is 8, right? 8 minus 7. So this will be equal to 1. Next 8 to 1. Delete second row, first column. So 1 into 1, 1 minus 3 into 2 is 6. 1 minus 6 will be minus 5. So minus into minus will be here plus 5. I hope you are understanding this one. Now 8 to 2. Delete second row, second column. So 2 into 2 will be 2. So this is minus into minus will be plus. 7 into 3 is 21. 21 plus 2 will be equal to 23. Next 8 to 3. Delete second row and third column. So 2 into 2 will be 4 plus 7. 4 plus 7 will be 11. Is it clear? So this is equal to minus 11. Now 8 3 1. Delete third row and first column. So this is 0 plus 3. So this will be equal to plus 3. Now 8 3 2. Third row, second column. 2 into 0 will be 0. 4 into 3 will be minus 12. Right? Minus 12 minus into minus will be plus 12. 8 3 3. Third row, third column. 2 into minus 1 will be minus 2 minus 4. So this is equal to minus 6. So this will be equal to minus 6. Now we got the adjoint of a matrix, right? So adjoint of A is, directly you can write this. See here, actually A11, A12, A13 is in the row. You have to write this one as a column, right? Because it will be a transpose. So directly we will write this one, minus 1, minus 4 and 1. So this is now 5. This is 23 and minus 11. So this will be 3 and this is 12 and this will be minus 6. So this is the adjoint of a matrix. Now you have to substitute in this formula. A inverse is equal to 1 by determinant of A is minus 3 into minus 1, 5, 3, minus 4, 23, 12, 1, minus 11 and minus 6. If you want, you can multiply this. At least multiply by a negative sign. Then you write the inverse of a matrix. I hope you understood this one. One more problem. Find the inverse of this matrix 3 by 3 because the trigonometric ratios are there. Actually, the problem is simple. Okay. First, you have to find A inverse. Write the formula always. A inverse is equal to 1 by determinant of A into adjoint of A. Before that, you have to consider the given matrix as A or B, anything, but you have to consider that matrix. Now, we'll find the determinant of A. Determinant of A will expand on the first row. So, this is now cos alpha into minus cos alpha. So, this is now minus cos square alpha minus sin alpha into sin alpha will be sin square alpha. So, you can take minus common. If I take minus common, remaining with cos square alpha plus sin square alpha, right? So, cos square alpha plus sin square alpha will be equal to 1. In minus is this, so this is equal to minus 1. Minus 1 is not equal to 0. So, the determinant of a matrix exists. We will find the inverse. For that, we have to find A11, A12, A13, right? A21, A22, A23, A31, A32 and A33. First, we will add the sign. So, this is plus, minus, plus, minus, plus, minus, plus, minus and this is plus. A1, first row and first column. So, same will get, right? Minus cos square alpha minus sin square alpha. So, it will be equal to minus 1. Is it clear? Similar to this one. Next, A12. Delete first row and second column. So, this will be 0. A13. Delete first row and third column. First row and third column. Again, this is equal to 0. A12 is 0, right? First row and second column. First row and third column. Both are equal to 0. A21. Second row and first column. So, this will be 0. This will be 0. So, this is equal to 0. A22. Second row, second column. So, this will be equal to minus cos alpha. Right. So, this is equal to minus cos alpha. A23. Second row, third column. So, this is now sin alpha minus 0. So, this will be equal to minus sin alpha. Now, A31. A31, third row and first column. So, this will be equal to 0. A32, third row, second column. So, this will be equal to minus sin alpha. A33, third row, third column. So, this will be equal to cos alpha and this is equal to 0. So, we got the values. Now, we will write the adjoint of A. So, adjoint of A is equal to this. Actually, this is a row, right? We have to write transpose of that. We write this one as a column. So, that is minus 1, 0 and 0, right? So, this is now 0 minus cos alpha, then this is minus sin alpha. Last row will be 0 and this is minus sin alpha and this is equal to cos alpha. Now we got the value of adjoint of A. You have to find A inverse. A inverse is 1 by determinant of A. Determinant of A is equal to minus 1, right? So we will multiply by the negative sign. Is it clear? Determinant of A is minus 1. So 1 by minus 1. So this is plus 1. 0, 0. So this will be 0. This will be cos alpha. This will be sin alpha. We are multiplying by the negative sign because determinant of A is equal to minus 1. So this will be now 0. So this is now sin alpha and this is minus cos alpha. So this is the inverse of a matrix. See here 1 0 0 0 cos alpha, sin alpha, 0 sin alpha and minus cos alpha. Both matrix A and A inverse both are same. If you multiply these two matrices, you will get the identity matrix of order 3 by 3.